Hello, grade 12. How are you? Um, Today I want us to look at differential calculus, which comes in paper 1. Before we look at that, let's revisit our analytical geometry, gradient. I hope we are familiar with this word gradient, talking about the slope. Assuming you are told to find the gradient of this straight line, 2x, we are familiar with y and also f of x. Y and f of x, they are friends. I would say they are family, like a father and a daughter. They bear the same name. All right. Okay. Now, assuming you have this um, question, find the gradient between x is equals to 2 and x is equals to 3. We are aware of this formula in grade 11, that to find the gradient is y2 minus y1 over x2 minus x1. If y is equals to f of x and is equals to 2x, then the formula can change. Instead of writing y2, we can write f of x 2 minus, instead of writing y1, we can write f of x 1 over x2 minus x1. So it's the same formula. The only thing is in grade 12, we use this one sometimes when we are finding the gradient, and another topic from here which we are going to treat, average gradients. Okay, so let's move on to the next slide. Okay, so this question is just refreshing our mind on gradients, how to find gradients, because we need those basics. So here, to find the gradients between x is equals to 2 and x is equals to 3, we substitute it into the formula. Remember, our formula is 2x. So when you see x, we are going to put x2. Which one is our x2? This is our x2, and this is x1. So this is x1, this is x2. It's your discretion. You may decide to call this x1 and call this x2. All right. Yeah. So here, this is my x1 and this is my x2. So here, this is my 2. Then my x is 3 minus the same 2, my x is 2, divided by my x2 is what? 3 minus 2. And this one, if you press on the calculator, let's see what you are going to have. This is my calculator. Where are you? Here you are. Okay, let's press that on the calculator. Remember, we are also learning how to use the calculator as well. So here, you use this, you press on this one. Then I'm going to press 2 times 3. So 2 times 3 minus 2 times 2, which is this one, divided by 3 minus 2. And this gives us what? 2. So our gradient for the straight line is what? 2. This is direct. We did this in grade 11. Okay. Now we come to grade 12. Average gradient. Grade 11 we did gradient, and now average. Where is this average coming from? You know, when we are finding average, we are talking about finding a mean, using one number to represent a situation. For instance, we can find the mean age of a class. We can use one age to represent the whole class. How do you find it? You add all the ages and divide it by the total number of people in the class. So we use the same idea here. Here you see that this is a quadratic graph, a parabola. How do you call this? This is what? A concave up. Concave up, like that. If it is moving this way, it is concave down. So what we have here, we have a concave up, a parabola. Another name is quadratic graph. And they are asking us to find the average gradient. Remember, a quadratic graph is not a straight line where you can only use 2 points. It has a lot of points, and the gradients are many. We can have these 2 points, these 2 points, these 2 points, because it's not a straight line like that where all the point lines can give you the same gradient. You can have different gradients. A point, like a point here and a point here, will give you a different gradient. A point here and a point here will also give you a different gradient, like that. A point here and a point here will give you different gradients. So we have a lot of gradients here. So what we need to do is we use one gradient to represent all the gradients. That's why we find the average gradient. How do you find the average gradient? It's not difficult. It's similar to finding of normal gradients that we are used to. Okay, let's see how we are going to find the gradients. Are you ready? Okay, I know you are ready because I know you are very intelligent. Okay, so here, how are you going to find the average gradient of this? The first thing we need to do is we need a formula. Remember, the formula will be given to us. If it is not given to us and a graph is given to us, we can use the graph also. So we are going to learn both. They want us to find the gradient between 1 and 2. How are you going to find the gradient when x is 1? So if we are using the graph, you come to the graph, x is what? 1. Remember, this is the x-axis and this is the y-axis. So here x is what? 1. So where is 1? This is 1. If x is 1, y is also 1. Alright, so x is 1, y is also 1. That's why we have this 1 here. If you are not using the graph and you are using the formula, you substitute x to be 1 here. So this side is what? 1 squared for this. Instead of writing the x, you write what? 1, then squared. And 1 squared on the calculator will give us what? 1. How do you press 1 squared on the calculator? This shouldn't be a problem for us. It's just 1 squared using this one. It gives us the same answer there. Okay, then when x is 2, using the graph, when x is 2, let's project it up. If you project it up, y is going to be what? 4. Y is going to be 4. If you are using the formula, you substitute x to be 2 here. So 2 squared. And what is that going to give us? 2 squared is what? 4. So 2 squared is equals to 4. We have that. Okay. Can we move on to the next slide? Okay. Now we are going to find the average gradient. When we're finding a gradient, we said y2 minus y1 over x2 minus x1. Another name, we can call it dy dx. That is changing y over changing x. And remember, I've already told you that the y2, we can write it as f of x2 minus y1, we can write it as f of x1 over x2 minus x1. Good. So here we have already calculated our f of x2 to be what? 4. And f of x1 to be what? 1. Remember, let's go back to the first slide. Remember, we calculated f of x1 to be 1 and f of x2 to be what? 4. Okay, let's move. So we have already calculated that. So what we are going to do, we are only going to substitute. So f of x2, you substitute 4. F of x2 is this one. So here where x is 2, you put is 4. Where x is what? 1, you put what? We have 1 there, all over x2. Our x2 is 2, and x1 is also what? 1. When you press this on the calculator, what are we going to have? We are going to have 4 minus 1 over 2 minus 1, which is going to give us what? 3. So we have this 3 here. So finding the average gradient is what? So easy. Okay, now let's move on to the next thing. Now this is leading us to something else. All right, I'll give you more questions on the average gradients, but I want us to move to something that I'm going to tell you later. Okay, average gradient. It assumes a straight line is drawn between 2 points. So if you have a straight line, you have 2 points like here and there, like this point and that point. So it assumes a straight line is drawn between what? 2 points, and the average gradient of the straight line is found. All right, so the average gradient of this one, remember this line has a lot of gradients, like as I've said before. So if we draw a straight line between this, we find the gradient of this straight line. So the average gradient of this between 1 and 2 is going to be what? 3. Doesn't tell us what the gradient is at a particular point on the curve. It doesn't tell us the actual gradient at a particular point on the graph. Okay, now assumes a straight line is drawn between 2 points on a curve, but that these 2 points are brought closer and closer together until the distance between the 2 points tends to 0. So we have 2 points on the graph, a point here and a point there, and you bring them together close to each other and you have only 1 point. The 2 points merge into 1 point. All right, if h is the distance, for instance the distance is, let's say, 2, then you decrease it and it becomes 0. We say that distance h, or the distance between the 2 points, then as the distance tends towards 0, we write it as h is equal to 0. I will explain it better. You will know the meaning of h as we proceed. Okay, in this way we can find the gradients of the points anywhere along the curve. So here we are trying to find the gradient of the points, not the average gradient. All right, gradient of a particular point when it's a point but not a distance. That is when the distance is what? 0. Okay, this one brings us to what we call limit. So here, this method of making a variable tend towards a particular number and then evaluating an expression containing that variable is known as finding the limit. So this can be written as lim, that is limit, a variable. That variable can be, let's say, h, x, y, etc. Let's say h approaches 0, h approaches 1, h approaches 5. All of them are what? Limit. Okay, now we are going to work some examples on limits. Assuming you are told to find the limits